Okay, welcome to our performance task number 4. And our performance task number 4, we will call this as our fixed resistors. We kind of may name it plural resistors because we will probably need some number of resistors in this activity. I will show you later now how or what is how does a resistor probably would look like. There are some of them that are available in a store, or you could get some discarded circuits. So if you can identify them, you can cut them out for this activity. For this activity, you'll need something like 5 different fixed resistors. But another way to secure 5 resistors is to find them instead in the net, as long as they are different from each other, and you could provide them as part of your diagram, the different resistors that you've used in the activity. Now, so again, we name the fourth performance task, and we are on our second quarter or on our fourth quarter coverage. And although this was a lesson discussed in the first quarter or in the third quarter, since the activity there is full, we move it a little later in our second quarter activity. So the objective of the activity is to determine, so if you're given a resistor, a fixed resistor, how do you know its value? So it is marked by some colors on the side. So with the use of those colors, we are going to figure out how much is the value of that resistor, of that fixed resistor, given the color code on the side of the device, or of the electrical component resistor. So again, how many resistors would you need or secure? Maybe you can buy an actual resistor, 5 different resistors. So they are quite tiny, very small. Or you could also get pictures in the net as long as they are all different, 5 of them. Now, after securing 5 of them, then maybe now you can post them as part of your diagram. Now, just to give you a brief run through of the different components of our performance tasks template. So there's a procedure that you have to fill up how the process was made in determining the resistance. How many ohms is there in your resistor? Then next is your table. So you will be identifying the colors, and we call it as color bands. So there are 4 colors that are found in your resistor. And with those 4 colors, you will write on this end of your table the value of the fixed resistor based on the given color. And then moving forward, so again, what you will be having here are the different colors. So what are the colors that you have there? Maybe red, orange, and so on. So you will label that with colors and color names, I mean. And then next is the value on this end. Now, to arrive at this value, you have to show some kind of a solution. So representing the different colors are values, some multiplier values, and this last column, I think, is called as the tolerance value. Now, we are going to explain the meaning of each of these columns here. And eventually, again, before you come up with an answer here, you have to show a computation for each resistor that you mark with several colors. So all these 5 resistors computation must be shown on this end. So you have to show it right here. Now, others would write a clean solution. Others would type an answer. Maybe create some kind of an equation in document in Microsoft and write the corresponding answer here. Now again, you can write your discussion, observation, analysis These are important parts, no, of your activity, and likewise your conclusion, no, once you are done with the activity. So again, no, the activity will require you not to find the value of the fixed resistor, no, given its color bands. Now you can think of discussing about resistances, no, and fixed resistors for your discussion. And then maybe with the values that you arrive there, now you can also make some observations and analysis. Now, here is your rubrics. Now, please don't forget, you can read through with the rubrics. So you will have there the opportunity to know, no, what are the things that you will be graded for. No? And next is the table or the resistor chart. No? So I think now this middle portion, I covered a value here because this chart is also used for a 5-colored resistor. No? So there are resistors that are colored, no, with 5 different colors. There are even resistors that are marked with 6. Now, since we will only be using a 4-colored resistor, 4-band, no, a resistor, then let's avoid, no, in opening this portion. So please skip this part. No, I just purposely cover it, no, so that we will only see, you know, the 4 color bands that are intended. Now let us name the different color bands. So this is the first color band. So the first 3 color bands are drawn or are marked at the middle part of the resistor, and then the 4th band is marked towards the side, no, the end of the resistor. No? So if you have a resistor there and there's a color band on the far side, then that means that that is your 4th band. No? 4th band. So you could look at the resistor's color somewhere in the middle, and then you go towards the end. No? Now each of these color bands, no, represent a particular value, especially the first 2. No? So the first 2 bands represents a value. No? So if it's black, then it's 0. If it's orange, I think that's orange, no? So if it's orange, or no, not orange, brown, I mean, no? So this is brown and black, no? So brown is 1, and then black is 0, no? So it means that if you combine 1 and 0, so the first 2 digits, no, or value is 10, okay? So it's basically 10, no? Now, the 3rd band is known as the decimal multiplier, no? Now for our multiplier, no? So our multiplier is equal to 1, no? If it's colored black, no, ang 3rd color, it's black. So you multiply the value of the first 2 by 1. So it's representing 1. Huh? So previously black is 0, but for a multiplier, we cannot multiply a number by 0 because it will become 0. So the lowest value for the multiplier is 1. Huh? So this is now, I think, orange, or no, red. No? So for red, we know that that's 100. So meaning you have there previously, no, 1 and 0, 10. 10 times 100, no? 10 times 100 gives you 1,000. No? So that's basically 1,000 ohms. No? So the whole value here is 1,000 ohm, but you notice that there's also a 4th band. No? The 4th band is called as a tolerance. No? A tolerance is something like a range of value, no? Where you will, no, assume, no, the value. So the initial value that we calculated is 1,000 because that's 1 and 0, so 10 times 100, no, a multiplier because it's no, the 3rd band is red, no. So it's 10 times 100, it's 1,000. So 1,000 will be added to a range, no, that will vary, no, from I think this one is similar to what color? Brown, or is it gold? No. Now, if that one is gold, basically, so we will be adding here, no, plus or minus 5%. No. So if you get 5% of 1,000, no, so I think that's 50. No. So from 1,000, the value of your resistor could decrease to as low as 1,000 minus 50 or 1,000 plus 50. So what we usually do is 1,000 plus minus 5%, no, of the value that you read here in your initial three colors. So usually, no, in this portion here, what we write, no, is simply 1,000 plus minus 5%. No? So that's now our value of the resistor. So the color bands again, no, you will mark here brown, black, red. No? And this one is now gold. No? So that is if you have your resistor. No? Now again, no, how do we interpret the values of our resistor again? No? So the first two bands again represents, no, the digits. So since it's brown and black, no, so it's 1 and 0. The third is red, so that's 100. No? So you look at the multiplier values, and then this last band is known as your tolerance. So whatever is the tolerance, that's the one that you will add and minus, no, from your 1,000. No? So that's 1,000 times 5%. So that's roughly 50. No? So but what you will write in your table is just 1,000 plus minus, no, 5%. No? Now you can also see that one here. No? So this one is marked red, black. No? So red is, from our chart, red is 2. And then black is 0. No? So it means that this is 20. No? So you have 20. And what is our next color? Yellow. No? Now for yellow, it is 10,000. So 10,000 times 20. No? So the initial value is 20, 20 plus 10,000. So the value here is actually 200,000. No? Because that's 20 times 10,000. That's 200,000. No? 200,000 in if you write it short, no, in a concise way. So that's 200,000 is 200 kilo ohms. No? So that's equal to 200,000. No? So 200,000 plus white, or I think is that white or silver? So if it's silver, no, okay, it's like silvery. No? So if it's silver, it's 10%. No? But I think, no, the last color here is not white, but no color. So if there's no color that you see on the side, no, or on the ends, then tatlo lang makita mo da, no, then therefore it is 20%. No? So again, no, so you have 200,000 plus minus 10%. No? So that's how you will write the answer here, no, in your table. No? So the table will contain the value of the resistor plus minus the percent expressed in percent, no, of your tolerance. No? So this is the only way that you will represent your answer. No? So that's 200 kilo ohms plus minus 10%. And again, 10% is the tolerance value. No? So tolerance value of 10% is representing the silver, no, color. No? So again, no, this is the whole template, and we are attaching it there. No? So I hope you understand the activity, and you can perform it together with your group. Now, I suggest that each member of the group will be given a responsibility, no, to have one resistor each, and therefore, no, they will have an obligation to give, no, the computation for that particular resistor. No? Okay, so I think, no, that's all for this performance task number 4.